This is Jeremy Cartie, your live stream astronomer, and we won't really be doing too much live astronomy tonight. Actually, I can take my mask off here. I'll show you. I'll talk a little bit about why, because I saw one of our moderators in the chat, Astronomy Web, mentioned that there are some stars showing through in Binghamton, and as I was watching the stream from Drew and Robert and and by the way, awesome presentations there. I saw that there were occasionally we would get a bit of a clearing, but we're also dealing with a wind advisory today. So first, I'm going to bring you down by the if you go to our website copernic.org, you can scroll down way to the bottom and click on the clear sky chart, and you can see that around midnight actually does start to clear up a bit.
Knock down your audio.
Oh, it's a little. Yep. Bring that down a bit. There you go. Now I won't be screaming in your ears. So, yeah, the clear sky chart is reporting. It's an average cloud cover here right now, which is about what I've seen when I've gone out there, and then it starts to clear up as we go into the later hours. Of course, that's also when the moon rises. So as it finally starts clearing, here comes the moon to brighten up the sky, and it's about 80% covered, or not covered, 80%. It's an 80% waning gibbous. But I did see Orion when I went out there. There are stars breaking through. So I encourage you, because this is our winter star party. Go out and see if you have clear skies where you are. I know maybe some people aren't even local to our area in Vestal, New York. So maybe see if your skies are clear, and if it's a little warm too, all the better. Here it's about, I think last I checked was 14 degrees, and it's dropping. So we're sub-freezing here. Not great for telescopes, and on top of that we have wind from 15 to 30 miles per hour. So not great observing weather out there. I did consider, going and setting up my camera tripod rig and getting some wide field shots for you, but even then, fighting the wind there, and I don't want to risk my camera today. So what we're going to do instead is we will go on a tour of what's out in the night sky tonight, and talk about some of future observing sessions that we can do. And some things to look forward to there. And that way, especially focusing on this evening's sky, we can go out and, you can go out and see if you have clear skies, compare what I show you today to what you have in your true skies. And we're going to do that using a program called Stellarium in just a moment here. First, I do want to bring attention, of course, most of our viewers are coming from our YouTube channel tonight, so we thank you for watching us there. If you have not subscribed to our channel, go hit that subscribe button if it interests you. We do a lot of observing sessions. We cover major astronomical events. We can scroll down here and you can see a bunch of what we've offered so far, including the lunar eclipse that was nearly total. There's still a sliver of light on it, but nearly total eclipse. That was very exciting. And of course, we post our regular Friday night live streams as well. We had an attempt at the quadrantid meteor shower just about a month ago in January, and that didn't pan out too well, but at least we got some nice views of the sky. It did clear up for us, just not many meteors to see. Going back to one of Robert's comics there, you look away for one moment and all of a sudden a bunch of meteors pop out. For us, we were monitoring the whole sky and no meteors showed up at all, except for maybe a few. I have the thumbnails saved there if you want to see them. But yeah, you can visit our channel. We also have a fundraiser going on our Winter Star Party live stream, and it's geared to support this stream and others. It will be attached to all of our major streams that come up, and maybe even some of our produced videos. And you can use that to support Copernic, our staff, our equipment, and support funding our future live streams too, and our future programs that we deliver to you virtually. So that's available on this stream and future ones too. Okay, so that's enough of YouTube. Let's go ahead and visit Stellarium here. I know I've probably talked that a lot of our viewers' ears off about Stellarium at this point if you frequented our channel. But for anyone new, this is such a great tool to use. If you want to explore the night sky and you have cloudy skies, you're in the middle of a city, so you have a lot of light pollution, anything like that, amazing tool. Or if you are preparing an observing event, or you're just preparing to go out observing with your own personal equipment, great tool to use to plan out your night as well, to see what's out there and what targets you want to go after. So this is what the website looks like. Again, stellarium.org. And you can download it for just about any computer that's out there. There is a mobile app, I think, on both Android and iOS. I believe the iOS one is paid, but in my opinion, well worth it. But you can also just view it over the web too. There is a web app you can utilize, and I think it even works on mobile devices. So it's the same idea here. And I'll show you the downloaded application, but that's what it looks like there. But there's less features in the web app, but it's pretty stable. It works pretty well. And if you're just want to go quickly look to see what's out in the sky, it will suffice. But I do encourage you to download the more advanced application. So we'll bring that up here. I'm going to full screen it. There we are. And, first I'll show you we can go back in time a few hours. Oh, you know what? Let's adjust these settings here, including the atmosphere. The atmosphere was turned off. We usually use Stellarium for our waiting room, but we turned it off for that reason. But I'll turn it back on so we can have a more realistic experience. And it really functions just like a planetarium. Copernic has a portable planetarium. We bring it around to schools. Just about actually anyone that wants to request it, we can prepare a program for you and price it out and everything. And we can bring it to as long as you have a place that accommodate it, high ceilings and a large room, then we can come show you our planetarium. But this is a planetarium at home that works on any screen. And the date and time button is right off to the left-hand toolbar. And of course, that's you have full control. You can go tens of thousands of years in the future or back in the past and see how the skies have changed. Astronomers have worked hard to model how the sky moves, how objects in the sky appear to move, and it's all baked into this application and others like it. So we're currently on Copernic's birthday, right? That's what we talked about earlier today, what Drew talked about. So February 19th, that is the exact day Copernic was born. It just so happens, usually we hold Winter Star Party on Saturday, so happens that it lined up this year for his 549th. So this year, today, February 19th, and then you have, I backed it up a few hours so that we could, so this is 3 o'clock, 3:04 in the afternoon. But I want to watch this sunset, so here we go. We'll go hour by hour and watch the sunset quickly. Now we'll just go minute by minute, and then you can see the stars start to come out. We're looking just about due south. We have a very expansive view, and right away you probably notice very famous constellation. And in the waiting room today, you actually were flying to that constellation, and we know that constellation is Orion. So I can turn on the constellation lines and names, so you can see Orion the Hunter in the sky. You can even turn on the artwork here, so you can see what sort of a little bit of the mythology behind it, what Orion is supposed to look like. I'll turn that off for now. And you can see it labels some of the brighter stars like Betelgeuse, this red super giant there. You got Orion's belt right in a row. You also can zoom in and see some deep sky objects like the Orion Nebula. So it's a really powerful tool that you can use to explore the sky. You can even bounce around to different planets too. If you wanted to go to Mars and set yourself up on that planet and see what the skies look like there, they're not too different because we're within our solar system. There's not going to be too much changes in the outer celestial sphere of all the stars, but planets will change, and you'll notice a few other changes too. Of course, there's no moon, at least not our moon, in the sky. There's a couple of others, Phobos and Deimos for Mars. You can also go over here and check out the Horsehead Nebula and the Flame Nebula. You should have, if you watched that whole waiting room video that we showed you in between breaks and at the very start of the stream, you should have been able to see the Horsehead Nebula and the Orion Nebula. But the cool part about that video is that you're not seeing it from a 2D perspective, right? You're not, for all intents and purposes here, when we're looking in a planetarium like this is a celestial sphere where you don't get much parallax. Things aren't really moving around each other. So when you zoom into Orion's belt, you're effectively just looking at a 2D image in the sky. Because things are just so far away. You're not going to notice things shifting like you do if you hold out your thumb and you close your eye, blink both eyes open and closed, you'll see your thumb shift, and that's what we call parallax. You don't get that in the sky from Earth's perspective because things are just so far away. But that video I showed you, we were moving way faster than the speed of light in another kind of program, not Stellarium, but similar idea, where you're actually able to travel through the universe. So you're zooming in and flying toward, actually not zooming in, you're flying towards. This is zooming in. In that program, we were flying towards the constellation Orion, and because of that, you start to see the Orion constellation fall apart, because the stars aren't in one plane. They are in their own spots in 3D space. So when you get closer to it, the constellation starts to break apart. You'll notice the 3 stars right in a row aren't exactly aligned along a plane. They are, again, in different positions in 3D space. And that's a powerful tool to show you that if you could travel way faster than the speed of light and explore the universe in that way, then you would really get a greater sense of how these things are positioned in 3 dimensions, rather than the 2 dimensions that we're kind of stuck with when we're observing from Earth. So I can sort of tease an idea that I'm planning on working on in the future. And the working title, I'm calling it Ponder the Cosmos. And it's going to use that same program to put together a series of videos and imagery throughout the universe. You can travel to exoplanets in that program. It's called Space Engine. You can go anywhere you want, and you can record video, and I'm able to share that video with you. And I know everyone, at least in the previous observing live streams, they've really enjoyed the the ambient music that we play in the background when we've done our waiting rooms before, and we included that in today's waiting room too. That's the idea. It'll be a more relaxing take where you can just ponder the cosmos. You can look around at the scenery of different worlds, of different nebula. You can go see the Orion Nebula in 3D perhaps, or visit the Horsehead Nebula in 3D and orbit around it. Visit a black hole. There's so much that can be done, and I would like to just try and share some of that video content with you, especially when we're in this period where we're fighting the weather. Super cloudy conditions this winter, and on top of that, cold conditions aren't great for scopes. So we're limited in what we can do when we're in this winter period, but as things warm up, we'll be able to go back into the live astronomy, and I have a couple of teases for that too on what we can expect to come up in the springtime. So keep on the lookout. We'll see if we can get a Ponder the Cosmos out there sometime in the near future. And it'll be a nice some more produced content rather than what we've been used to this point, which is live. That's not going away, of course. It'll be some produced, some live, and of course covering all those major astronomical events. Okay, so let's get back into thinking about our night sky, if skies are clear for you where you are. We talked a lot about Orion there. I got a little sidetracked, but you know me. I'm always getting sidetracked. Which is okay. There's a lot to talk about. You'll see Orion is almost due south as the sun sets, and you can expect that to be the case for at least, another few weeks here. It's a winter constellation, so it's being presented nice and centered almost in the sky. So let me know in the chat if you were able to spot Orion where you're located. Go outside, see if you can find it, and report back here. It should be. You can easily spot it with those 3 stars right in the row making up his belt, right? And then look above to his shoulder to see if you can see the bright red star Betelgeuse. Now, if you go below the constellation Orion, you come to one that's also nearly due south, more southeast right now. Actually, if we go to current time, there we go. It is due south now. So we were a couple hours back at 6 o'clock. Now we're at 9 o'clock, 9:12. So this is current time, the current sky. So Orion has started to move southwest. We have Canis Major due south. You'll see in Canis Major is the big dog. And this dog has a very fancy collar. We call that star Sirius. Sort of has a jewel in its collar. And we can zoom in here. You can see it's very bright. It's a magnitude -1.45 for those who know about astronomical magnitude. That's a measure of brightness. Negative numbers mean very bright, for those that don't know. You can compare that to Betelgeuse, which is positive number, 0.45, meaning it's a little dimmer than Sirius. So Sirius is a super bright star. So that means if you went outside right now to follow, to go and search for the brightest star, don't go thinking that bright star is the North Star. It's a common misconception, and if you do that right now, you're going south. You're going to flip your whole compass around. So if we go to the northern sky, the exact opposite, you'll see the North Star is at the tail end of Ursa Minor. North Star is called Polaris. And it's much dimmer than even Betelgeuse there. It's about a magnitude of 2. So it's not terrible. You can see that with your eye. But if you're searching for this bright star, thinking it might be the North Star, that's not going to take you where you want to go. Your whole compass, like I said, is going to be flipped around. So Sirius is a very nice star to look at. But if you're lost, you need to find the North Star to get your bearings. And the best way to find that, because it's a little dimmer, and the constellation Ursa Minor is pretty dim too. All these stars in here are super dim. 4.35, 4.2, those are very dim stars compared even to the North Star. So instead what we do is we use the Big Dipper. All these stars are nice and bright, very similar in brightness too. So it's very easy to put together the Big Dipper in the sky. And once you find the Big Dipper, you can use the 2 stars in this part of the cup and line them right up with the North Star. See that? You line right up, and that, or you can also think about it like the open end of the cup is always facing out towards the North Star. And I'll prove that to you here. We'll do some time traveling again. So this is our celestial sphere. You'll see when we travel through time, the stars move with the celestial sphere. Going minute by minute, you see Orion is moving with the grid, rotating with the grid. So what we can use this celestial sphere for, or at least it gives you some perspective on, is if you took, our Earth and you projected a sphere further out, an imaginary sphere, and you mapped that, you were syncing that up with the stars in the stellar background. That's what you get. You get this coordinate system that we use as a celestial sphere, and it's all aligned with the Earth's poles, so it'll rotate around the same axis as the Earth. So the North Pole of the Earth points right into this position in the sky, right about where the North Star is. And then if you could see it, which I will turn off the ground so you can, the South Pole points right into that part of the celestial sphere. So the sphere rotates, and it's rotating at the speed of the Earth's rotation, because that's what's causing that motion in the sky, so to speak. It's all relative on how you think about it, but the sky appears to move because we're rotating. So this is a way to map that out, and if we start traveling through time, we'll speed up the clock here, you'll see the Earth starts to rotate, and by consequence the sky is rotating. But is the North Star really moving much? We can even zoom in to really get a perspective on this. It's moving ever so slightly, around this true north axis. So that's the actual point the sky is rotating around, and then you have the North Star orbiting around that point. So let's go back to current time. Now you'll see there are stars that are even closer to that due north point in the sky, but you'll notice they're much, much dimmer than the North Star. These two are magnitudes 10, which is not visible to the human eye. So that's why we choose Polaris specifically. Also worth mentioning, Polaris just so happens to be a very convenient North Star for us right now. It isn't always, and it won't in the future. Thousands of years from now, it won't be a good North Star to use. It'll be too far off, and you'll have to. It'll be somewhat close. It'll give you a rough estimate of where true north is, but you'll also have to get a sense of how far off our celestial sphere is. The northern axis of our celestial sphere is from that North Star. So it's pretty fascinating. It's actually right now, if we travel year by year, you can see the North Star move, and it's getting a little bit closer to that northern axis, but it is moving off. If we travel, let's go to the year 5,000. 5,000. Look how far away it is in the year 5000 from that northern axis. It really veers off. And that's due to the Earth's precession. You can think of a spinning top, right? As a spinning top slows down, its axis starts to swivel like this and precess around. That's what happens with our rotation over many, many years. The axis starts to point in different points in the celestial sphere, and that means we lose the North Star. So, we have Cepheus here. In the year 5000, we can maybe use as our northern constellation. Ursa Minor and even Ursa Major are getting closer to the horizon there, so they're not as good stars to pinpoint. In fact, in the year 5000, you have this point in between the triangle of Cepheus that might be sort of centralized or almost equidistant from all 3 points. That might be a neat way to do it, but of course we don't have to worry about it. The North Star for our lifetime will be Polaris, and that's what we can use. A little bit of fun history about the sky, and talking about the future too, of how our skies will change. They're not constant. Alright. Now, is there anything, if anyone would like to post in the chat, I always like to refer back here. Is there anything that anyone would like to see in the sky that they might know is out, but they don't know exactly where to look? I'm happy to answer requests there or any questions. We do have the moon rising up in the eastern sky. Oh, Pat from our Copernic Astronomical Society says that he had a star show through a very small hole in the clouds in Enwell. So there's another report of some stars breaking through where we're located on this windy and cloudy and cold night. Linda says, we went past Betelgeuse early in that travel. Yes, on that video in our waiting room. Betelgeuse started to move pretty early as you started to fly through space towards Orion. And that's because it's reasonably close compared to the other stars that make up the constellation Orion. Great observation there. AstroWeb says, hopefully someday we'll be able to visit other stars in person. Yes, hopefully someday. You know, the nearest star is a couple light years away, so hopefully we can design a spacecraft in the future that can at least get there in a reasonable amount of time. Maybe not the speed of light, but, you know, a fraction of it, and then we can start to explore extrasolar, beyond our sun. Or exosolar, I should say. Okay. So, yeah, like I said, we do have the moon coming up in the eastern sky now, and I think it is a waning gibbous. So we're past full moon, yep. And you can see if we advance the days here. Oh, I got to turn off the ground to do that, though. If we advance the days, we start to lose more light on the moon. But it is above the horizon, so if you go outside, you might be able to spot the moon. Nice and bright, maybe a slight colored reddish hue to it. Oh, what else is it? Now, planets. Not a lot of planets out there that you can see with your eye. Here's, if we zoom in here, Uranus. You can zoom in Stellarium and see what Uranus should look like with all its moons and its ring system. It is out there. You can find it with the telescope, but again, it's not super bright. It's going to be hard to spot. And also, with a telescope, it's so far away and it's smaller than the larger gas giants that are closer to us, like Saturn and Jupiter. You can't make out a ton of detail on it. You can just about see maybe some of that bluish color come off it, and you'll start to see it's a disk rather than a point star, point light like the stars show you. But that's a challenging one. Let's put up the ecliptic so I can see if there's any other planets out there. The ecliptic helps us find planets, the moon. The sun also follows the ecliptic. Oh, that's the grid. Hang on. I need this one. There we go. So you can see Uranus is following along the ecliptic. And that's about it. Yep, I don't see another one. I thought Neptune might have been out. Let's see. Nope. It's below the horizon too. Only Uranus right now. So not much in the way of planets in the winter time right now. I think Jupiter may have set. Where's Jupiter here? There's Neptune. Oh yeah, Jupiter is very close to the sun now. So not much chance to spot Jupiter with your eye. Maybe you could catch it. How close to the sun is it really? Again, we're backing up in time to see where these planets are. Oh, there's Neptune. Jupiter and Neptune are pretty close in the sky right now, and you might be able to. It's pretty close to the sun. That'd be a challenging one and a little bit of a dangerous one too if you're not exactly sure how to go about it. So we'll go back to current time. So yeah, not many planets. Let's travel forward. So we're at current time. Let's travel hour by hour forward into midnight. That's where we are at midnight now. And here's Venus rising up, and with Mars, in fact. So Venus and Mars are almost right in a sort of cool line there around the ecliptic. and Mercury follows. So as you, if you wake up early, around 6 o'clock, maybe 5:30, you can go outside and look to the southeast and spot a couple planets. Mars is going to continue to get brighter and rise at a more convenient time as we head later into 2022. December is going to be the close approach, so that's an event to look forward to, where we'll start to you'll start to see astrophotos from Mars a lot more as we get closer, because it's a great time to observe as we head later into this year. So look out for that. It'll continue to move westward as time goes by, so it will rise earlier and earlier in the evening, and you won't have to wake up at 6 or 6 in the morning to look at it. All right. Now, on a similar note here, I did want to mention one of the events coming up. If you are, an early bird astronomer, it's April 30th. Oop. I lost my screen. There we go. Sorry, my screen turned black for a second there. Okay, anyways, April 30th to May 1st is the conjunction of Jupiter and Venus. So to show you a little bit about how powerful this software is, we can again travel. I mean, we already traveled 3,000 years in the future, but let's travel a few months from now into late April. So April 30th. And we're going to back up time because you can see the sun is rising earlier in the morning on April 30th here, so we got to bring the sun back down. And you can see on this date, Jupiter and Venus are right on top of each other. Try and center them there. We can zoom in. And that would be probably a pretty neat view through binoculars. You might be able, in a nice wide field, you might be able to capture the moons of Jupiter and Venus as well. And I'm not sure if Venus has any phase at all. It's a gibbous Venus, but that would be noticeable. You'd be able to see that it's not a completely full circle view of Venus. It is cut in a gibbous shape, or it'll look more oval shaped in your eyepiece or in your binoculars. So that might be a neat event to focus on. One of the events I wanted to mention, actually, for an observing live stream. So we'll maybe pencil that one in and get a live stream link out there so you can look forward to that. We'll need to figure out some good wide field equipment to display that one over a virtual environment, but I think we can do it. At the very least, we can bounce between the two without much problem at all. It'll be really easy. But that's sort of in a similar, not as close as the Saturn-Jupiter conjunction, but those are pretty close together. Saturn and Jupiter conjunction was last December 2020, I believe it was. Yes. So that's a cool event coming up. Another one I wanted to discuss is also in May. Again, lots of springtime events this year. Not many amazing meteor showers coming up. The Aquarids are the one that, again, also sort of appear in the springtime. And they, I haven't heard amazing things about them, but you can be aware that they're coming up. We try to focus on the ones where we have a good chance of spotting a few. During the course of the live stream, like the Perseids are always a good event in August. So here you have a bunch of planets lined up that maybe we could just do a marathon of on that same day. You have Saturn, Mars, Jupiter, and Venus. So again, pencil that one in. That one's pretty exciting. Now let's go back to current time, and we're going to focus on the moon here because, like I said, on May 15th, there's a lunar eclipse. So let's travel forward to May, and we'll go back to 15. Zoom in, and let's see what happens as we travel through time. There we go, the eclipse has started. The umbral eclipse. So we saw the penumbral a moment ago where it was just slightly shadowed. Now this is the umbral, where the actual shadow of the Earth is coming through. And this is a total eclipse. Do you see, even in Stellarium, it's modeling it pretty well. Do you see how we have a fairly bright moon here? It's going to be slightly shadowed from the penumbra. But as you travel further and the umbra covers it more and more, and that brightness of the moon goes away, and you just get full shadow, a blood moon, the stars start to brighten up in the background, and that's very true. You do get to see more starlight on a full moon night. It's that rare occurrence where the full moon isn't so bad because it's doing its own exciting thing with the lunar eclipse, and on top of that, the sky is get nice and dark because of that shadowed moon. So it still glows, that red color, and that's because of that light scattering in our atmosphere, the sunlight, and then it's shining on the moon, just like a sunset. Same idea where that color is coming from. So that'll be pretty exciting. That's May 15th. So I'll be busy. April 30th into the May 1st is the Venus-Jupiter conjunction, and then May 15th is the total lunar eclipse. So unlike the November 19th eclipse we had just a few months ago, that one was almost total, but still a sliver of light, so it wasn't a pure blood red moon. This one is going to be a total event. So even if it's cloudy here, I'm going to do my best to hunt that down in a clear sky area and hopefully stream it out to you as long as I have good enough cell coverage. So we will do our best there. So let's go back to current. I think, yeah, those were the only two I wanted to mention in the short term for events I will definitely cover. That's not to say I won't be doing more live streams here. I do want to do one for February on one of the warmer days coming up, hopefully this month sometime. So we can operate the scopes and I can maybe hunt for some deep sky objects. Then heading into March, I'm sure we'll have some. We'll continue to get warmer weather as time goes by and we enter spring. And then I can, and as we head into the spring, that's a great opportunity to search for some deep sky objects that are out there. They really start to pop out in the springtime. Just again, how the sky rotates and how we're orbiting around the sun, they start to appear. Those nice deep sky objects, like a bunch of galaxies. Things like the Whirlpool galaxy starts to come back around, and there's a lot to observe there. Let's check out the chat here to see if I've missed anything. Oh, Pat says the Rosetta Nebula. Now, I don't know that one by memory, so I'm going to search, and it's something you can do too. If there's an object that you don't know, you can always search. Oh, I guess it does have to have me type it all the way. So we're going to the left of, or I guess eastward from Orion. And there is the Rosetta Nebula. This one, let's see, is it going to tell me? See, I'm not clicked. Oh no, I was clicked on it before. Let's do the search again. Rosetta. It's not telling me the magnitude up there for some reason, the average magnitude of it, but that's okay. So if you want to provide some specs on that, Pat, you're welcome to. Just because I can't speak to this one too much myself, having not fully observed it. But that one's again east of Orion. What else do we have? Jcash is asking Andromeda. Where do you find Andromeda? So Andromeda is getting a little bit more challenging to find in the sky, and it will start to go away as we head into the spring and then into the early summer. It'll become a little bit more challenging to find in convenient hours. But it is out still right now at current time, and it's setting in the western sky, sort of northwest. Almost due northwest. So you go to the constellation Andromeda. So it'll sort of be this line of stars sticking perpendicular to the horizon. And we'll zoom in on this one here. And I usually, I have a good, at least when I'm observing it out in the night sky, I like to count the stars from Andromeda. When you see the full constellation, so you sort of count 1, 2, 3, and then double count the star 1, 2, 3. And you can find the Andromeda galaxy itself. So again, 1, 2, 3 stars in the Andromeda constellation, and again, 1, 2, 3, perpendicular to that line, and boom, we can zoom in a little further, and there's Andromeda. So unless you're in a very nice dark sky spot with a really clear view of the horizon, if you went out right now, you would have a fair bit of trouble trying to find that one. It's not super bright, but it is visible to the eye in dark enough areas. And it looks really nice through binoculars. It starts to pop. But we've also already are a few hours into darkness. So if we back up to 8 o'clock to 9, we're 8 o'clock here at 2000. 7 o'clock, 6 o'clock, sky starts to brighten again there. So we're going to travel to exactly 7 o'clock. And it's a little higher in the sky. You can see Pegasus down here, and here again is Andromeda. So if you get out there right as the sky darkens, and if you have equipment to set up, set that up as you have some light still, and then you can go on the hunt for Andromeda as it starts to set in the western sky. And you'll have a decent amount of time. But like I said, we are going to lose Andromeda, the Andromeda galaxy, eventually here. And it'll swing back around and start rising in the early morning sky as in the summertime. But eventually it'll be, I think, if we do this right here, I can show you. Let's go, we'll turn the ground off, and I'll show you where Andromeda is going to head. You can already see it's getting close to the sun. So if we go month to month, next month, it's going to be almost right above the sun there, and it'll make its way around. So like I said, once we head into the early summertime, we will start to have a better time observing. If you're an early bird astronomer, you will have to wait until later summer and into fall to start seeing it at more convenient hours again. But for now, take the opportunity while you can to see the last bit of Andromeda before it goes away next month. Okay, current time again, and we'll turn the ground back on. There we go. All right, looking back in the chat, we have a request from Janet. Can you speak a bit about the southern hemisphere? So I'm currently actually in the process as we work on our planetarium programs. That's something we're really want to focus on soon, is observing the southern hemisphere and displaying it on our nice, spherical screen. So you can kind of get the experience of what it's like to be down in the southern hemisphere and what the skies are like there and how they're different. But you can think about this, like if you're in the northern hemisphere, you're missing out on 50% or more of the sky, because we're a sphere, right? So we're only going to be able to see so much of the sky at one time. So if we turn off the ground, you can see the rest of the sky there. So all those constellations, especially those ones that are due south around the South Pole. Remember, that's the South Pole there. If we could look above where the North Star is, that's the north. So there's the south polar axis. You can see a bunch of constellations that those in the northern hemisphere are not familiar with at all. And I'm not familiar with these either because I've never seen them in person. I may have seen a couple of the ones that hang out closer to our horizon. Because the furthest down south I've been is Costa Rica, so I did get to see some, but I was also pretty young, so I don't remember much. but you miss out on a lot. If you want to see a lot of these, you have to go below the equator. So we're working on putting some projects like that together, so you can see, okay, here's our northern sky. You should be familiar with this. Let's fly south and see what our southern hemisphere looks like. And we have a program similar to that you may have seen. That's sort of a holiday-themed one, and we were sort of working on that for Holiday Horizons before we had to cut that program. So we're working on that, and hopefully we can provide you with more information, especially as I continue to learn more about the southern hemisphere myself. So, but that's what it looks like, when you turn off the ground and you can see it. So if only we could turn off the ground in real life, we could spot it. But then where would we even be? Okay. Great requests, great questions, everyone. I see they're still coming in here, so okay, so Happy has some questions about where the colors in the sky comes from, and maybe referring back to that blood moon that we were getting. It's just like, you just think about it like a sunset, right? Think about it like the sun getting lower and lower in the sky, and then all of a sudden, instead of blue skies, we have red skies and pink skies. And that's why, again, that light from passing through our atmosphere and hitting the moon during a lunar eclipse, why it turns the moon a reddish color. It's simply just due to that light getting scattered in our atmosphere. It's similar things happen on Mars, for instance. It has an atmosphere too. But I think it's flipped for Mars, where the skies are sort of a reddish hue in the around noon, and as the sun starts to set, it gets a bluish color on the horizon. So it's not a unique phenomena for sure. And I was actually paying attention to that when I was using the Space Engine program today to make that Orion trip to Orion that we saw in the waiting room. It also simulates that effect. So when you're looking at the sun through thick layers of the horizon, right on edge, you get the reddish hues. But if you simulate it being right above your head and you're looking at the sun from the ground of Earth, you get those bluish hues. So pretty powerful software, that, and it's just a natural phenomena. Nothing too scary there. Oh, Deb is reporting from where they are, a nice moon peeking out between the clouds here in Marlborough. Very nice. Yeah, that's great that we're getting some reports here. Let me know if you're seeing any objects out in the sky where you're located. Again, I think we probably have some partly cloudy skies here, but again, it's just so windy, and we have a wind advisory. I don't want to risk our equipment too much, because then if we risk the equipment, then it's gone, and we can't use it for future events. So we're going to conserve it, and then hope for some clear and warmer nights coming up. Start reading through another chat here. Oh, Jcash is saying going to Southern Africa in May and would love a tutorial on southern skies. Okay, I can, I will pencil that in my potential programs that we can try and send out to you virtually. Again, something I could even maybe do in that same program I used for that Orion flight. I got to learn more, because it's not something I can just do readily. I don't want to wave my hands too much. I'm doing that a fair bit already. So without nice conditions out there to observe. All right, did I miss anything else in what I wanted to talk to you about today? Again, if you have a request on something you wanted to see in the sky, let me know. We talked about Andromeda. We talked about what planets are out, and there's really not many to see. not much deep sky to see tonight. Now that the moon is above the horizon, it's a bright enough moon that you're gonna start losing more and more of the sky as it continues to rise. So that's a bit unfortunate, but that'll pass. We'll get our dark sky nights again soon, and actually pretty soon now. In fact, early on tonight, if you went out, there was no moon, so you could observe quite a bit, and that will continue as we approach new moon here. So Ursa Major here, we will continue to have that rise up further in the sky. Oh, that's the wrong one. Hang on. Turn that off. And we will be able to start seeing this clearer. This is the Whirlpool Galaxy. I mentioned this earlier, and partially why it's such a nice spring object is because it'll be nice and high at the sky at a convenient hour, and you'll get some nice clear views of it where you're not looking through too much of the atmosphere. And unfortunately, our northern skies here are the portion of the sky that's the most light polluted. It's not terrible, and sometimes you get a low-lying valley fog, and that blocks a lot of the light pollution down below in the city area. But if you're looking at our entire sky, you'll definitely notice, okay, there's a bit of a glow in the north, but then you look due south and it's nice and clear. So that's good that our southern skies are nice, but the higher this gets, the better for us and the better it is for imaging. Oh, and that goes in general too. So that's a Whirlpool Galaxy that we'll watch with great interest as we head towards the springtime. And we're still at current time, so that's right where it is in the sky right now, if you wanted to go hunting for it. It's something you need a good size optic for to brighten it up. That's a magnitude 8, which is not visible to the eye, but would be visible through a telescope. Pat asks, did you already cover the brightest thing beside the moon and the sun is Sirius? Yes, we did talk about Sirius, although I don't know if I mentioned that it is the brightest object there in the sky. I'm not sure. I talked about it's the brightest star currently, but I don't think I emphasized. Yeah, it's the brightest thing that we can spot in the sky, other than the moon and the sun. So we can compare that right now. Here's the moon, not even at its full brightest. Moon is a -12. If we go hour by hour to the sun, moon is -26. And even Venus here, where's Venus at right now? Venus is at -4. But as far as stars go, and as far as what's out right now in the sky, only the moon is brighter than Sirius. Sirius is the brightest one out there. So again, don't go mixing it up, thinking it's the North Star. You will not go the right way. Not good. Oh, I should have mentioned Taurus the Bull here too, with the very famous star cluster, Pleiades. So there's Pleiades. Nice binocular object. Really big, and I'm sure you've seen it with your eye before too. Nice cluster of stars. If you expose just right with a camera, you can capture some of this nebulosity. I always like to refer, in this one area of the sky, you have the Orion Nebula, which is a stellar factory where stars are being born. And then you have the next phase of stellar evolution, where you have an open star cluster where those stars have formed and there's not really much gas to generate new stars, and otherwise now the stars are spreading out into space, forming their own little solar systems. How about that? So you have two important steps of that stellar evolution that you can observe just by moving your head ever so slightly, at several degrees, from right now southwest is where Orion Nebula is, and then to due west where Pleiades, or the Seven Sisters, are. Okay. So, that about covers what I wanted to discuss at what's in the current skies right now. There's so much more out there, and I encourage you to explore this tool yourself. But I think that was a pretty, decent planetarium show I was able to provide you there for tonight. I wish I could have giving you the real skies to look at, but we will try again next time for that. I mentioned, again, I'll review here. I want to start putting together some more produced videos, like the Ponder the Cosmos working title I pitched earlier. And that's going to be through Space Engine. So look out for some of those, and I love your feedback on that. And we can, I always like to reach out to the community and collaborate a little on how we can change, improve our programming and cater it to you. So look out for a test video. Maybe I'll even throw up the Orion flight to Orion that we saw earlier, so you can watch it on your own time. So look out for those. Then we have, in March, I'm definitely planning some deep sky observing session, and I'll try and fit in a regular lunar observing session then too. So prioritizing deep sky though, because we've observed the moon a lot. We'll observe the moon a lot in the spring with the total eclipse. So prioritizing deep sky, because we haven't done one of those in a while. So that's March. April 30th to May 1st is the conjunction of Jupiter and Venus. It'll be an early riser, but I think worth covering because there's a couple of other planets out there, like Saturn and Mars, too, to observe. So planetary observation in April with the conjunction as well that we can get a nice wide field view of. And then May 15th is the total lunar eclipse that we will definitely cover. It's at a much nicer hour than the previous eclipse that was, 1 a.m. to 6 a.m. So this will be more 9 p.m. and then total eclipse is around midnight. So not too bad. You can get to bed at a more reasonable hour, and not have to wake yourself up super early or stay up all night with me. So we'll try and cover the entirety of that. Probably ends around 3 a.m. But we'll keep our fingers crossed for clear skies up here. Otherwise, I'll go visit another clear sky location. We went through Stellarium. Again, go to stellarium.org if you want to learn more about the sky. Where you can, if you're not local to us, you can just change your location using the location window here. You can go anywhere in the world and see what your skies. You can go to Antarctica if you wanted to, or the North Pole, and see what the skies look like there, or visit another planet. So there's a lot of options for that. And I encourage you to download the software or visit stellarium.org and use the web application there too. Jcash brought up the topic of the southern skies, and yeah, I'll see if we can push out some kind of content for the southern hemisphere at some point. It would be an interesting program to cover, and maybe we can fit it in to our regularly scheduled Friday night programs. That's probably a good way to go about it. So actually, let me write that down, because we have not talked about that in a while, I know, even in our in-person programs. So it would be interesting to cover. And then lastly, I will tease a final produced video that I am currently working on, which has to do with James Webb. And there's a lot coming out from James Webb already. It kind of technically experienced its first light, but it's not a cohesive first light. The mirrors are still calibrating and they're aligning, so they can all function as one big mirror rather than 18 small mirrors. So they're still calibrating. There was a really cool image that came out yesterday or the day before that showed the same star, but from each individual mirror. So it was 18 images of the same star from one of the 18 mirrors, and they're using that to calibrate. So eventually it'll just calibrate to one single point star. And the coolest thing about it is that they've set it up now so the pattern matches the design of the James Webb. So that's part of the calibration process. Now it fits that same hexagonal shape that James Webb, the primary mirror is hexagonal. So pretty cool there. And then, yeah, so look out for that. I won't tell you exactly what it is. I'll keep that a secret for now. But there is a James Webb video coming that I'm pretty excited to put together. Hopefully I can get that out in March sometime. Oh yeah, Patrick Pat says JWST first light and the selfie too. So yeah, the first light image wasn't that patterned one. It was kind of sporadic, where all these little stars of the same star from each mirror. But on top of that first light, there was also a selfie image that it took from the engineering. As I understand it, it's an imager used to calibrate James Webb. It's where these images are coming from, and it was actually able to take a picture of itself, sort of. And you can actually see that primary mirror. It's not something that will continue to be used necessarily future in the mission when it's actually performing science and collecting data, but for calibration purposes, it was able to take a picture of itself. So look those up too. Let's see. Did I miss anything else? Oh, as Pat also said, happy Mikołaj Kopernik Day, everyone. Yes, we'll say happy birthday to Mikołaj Kopernik once more. Again, his 549th birthday. Very exciting. And then Tabitha says there's a Northern Lights live event in March. Oh, that's interesting. Feel free to post in the chat where that may be happening. We've tried to cover some of the Northern Light opportunities here at Copernic, but it's very rare for them to come this far down south. We're at 42 degrees latitude, so we don't get them often. We have some great images from 2003 where they showed up. But not too often we get them. Maybe as we get closer to solar maximum, we'll have that opportunity. The sun's getting more and more active, and will continue to do so over the next few years. So, pretty cool there. And maybe, but look out for some maybe a Northern Lights live event. I would be interested in that for sure. Okay. Well, with that said, I want to wish everyone a happy Winter Star Party. We're so happy you were able to join us virtually through our YouTube channel, and also this is still streaming out on Facebook Live as well. So we thank you for your support too, both just being here and talking with us and sharing in discussions about astronomy and the scientific fields in general. And we will look out for those future observing sessions. Live stream links will be posted, and we'll continue to interact with you on all our social media, Twitter, Facebook. All those links are in the video description if you'd like to follow us there. Thanks again to Drew Desker, our director, for the amazing presentation about Copernic and why we're celebrating Winter Star Party, and that this is actually Copernic's birthday, which is really cool today, February 19th. And thank you to Robert Nyai as well for his amazing presentation, and also very entertaining and funny one on all those comical comics. So with that said, we'll use our slogan, look up and dream big always, and we will see you next time.